Hey guys, welcome back. Today is day 48. We're going to talk about systems of inequalities. So hopefully you started off and you did your warm-up, and we're going to go over it now in the video. So the first thing we're going to do, this is just, we just have one variable, so we're going to solve this inequality. We've got 4x minus 2 is less than, after I distribute, I've got 10 plus 4x. So when I subtract 4x from both sides of the inequality, I end up with negative 2 is less than 10. Well, that's a true statement. So since it's true, I know that my solution will work for any real number. And how I graph that is just a line above the number line there. So it's all real numbers is our solution. Number 2, to state whether the following ordered pair is a solution to the inequality, I simply plug the x and the y values in. Okay, so we've got 2 times 0 minus 3 times negative 5. Is that less than 6? 0 plus 15 less than 6? Yeah, let's see. So 15 is less than 6. That's false. So we know that this is not a solution. No. Okay, the next one in the warm-up, we want to know what inequality does the shaded region of the graph represent. So looking at this, our y-intercept is at -1 and our slope is at positive 1/2. Okay, so I'm going to look at the point 0, 0 is in the shaded region. Okay, or you can think of this as the y-intercept is shaded above the y-intercept, so we know it's going to be greater than. But because it's a solid line here, this right here is solid and not dashed, I know it's going to be greater than or equal to. So putting the pieces together, putting it into slope intercept form, my y is greater than or equal to 1/2 x minus 1. There's my inequality. All right, now the fourth one, we want to graph it. So the first thing I'm going to do is put it into slope intercept form. I'm going to start by subtracting 4x from both sides. Okay, so I get negative 2y less than or equal to negative 4x minus 10. And then I'm going to divide both sides by negative 2. So I'm going to be careful here because I'm dividing by a negative. I'm going to remember to flip the inequality symbol. So we get 2x plus 5. All right, so to graph it, I'm going to start at my y-intercept, which is at 5. Okay, and then from there, I'm going to get a slope of 2. So I'm going to go down 2 and over 1. There we go. All right, so it's a solid line. It's greater than or equal to, so I'm going to have a solid line. And now to shade it, because it's greater than, I'm going to look at my y-intercept, and it's above the line, so it's going to be shaded here. Okay. So let's move on to systems of inequalities. So a system of inequalities consists of 2 or more linear inequalities that have the same variables. So we're going to have 2 variables. The graph of a system of linear inequalities is a graph of all solutions of the system. So the area where the shading overlaps represents all the solutions of the system. And again, don't forget, when you multiply or divide by a negative, you flip the inequality symbol. Okay, so we're going to start with the first example. So here we've got a slope of -1. Whoops, let me clear that out. Okay, so our slope here is -1 and our y-intercept is -2. So I'm going to graph this one. All right, so this line right here is going to look like this, and because it's greater than, it's going to be a dashed line. Okay, so now when I look at the dashed line, all right, I'm going to look for my shading. It's a greater than symbol, so I'm going to look at my y-intercept, and since it's above the line like that, I'm looking for it greater than. So I'm going to shade the value. I'm going to shade this side right here to make it greater than. Okay, you could also put in 0, 0. 0 is greater than -2, so the point 0, 0 is in the shaded region. All right, the next one, my slope is going to be, let's do this in blue. Slope is going to be 3. The y-intercept is going to be 5. So we're going to start at the y-intercept of 5. I'm going to go down 3, 1, 2, 3, into the left 1. Okay. All right, so this one is going to be a solid line because it's less than or equal to. All right, now because I want my shading, it's actually going to be less than, so my shading is going to be, think about the y-intercept, it's less than the y-intercept, so it's going to be down here. And if you notice, I have a double shaded area. This is where the solution is. So this area right here, and I'm going to write the word solution in. Now remember, we use the dashed line for less than or greater than, and we use a solid line for less than, equal to, or greater than or equal to. All right, so if you want, you can try number 2, but I'm going to go ahead and do this one. My y-intercept is at -4. My slope is a +1. So that's going to be a dashed. I'm looking at the first equation right now. I got a dashed line there. Okay, and with the dashed line there, it's going to be less than x minus 4. So I'm going to look at the y-intercept, and I'm going to shade below for less than. Okay, now I look at my other line that I've got, and y is greater than or equal to -x plus 3, so my y-intercept is at 3, and now my slope is a -1. All right, and this time the line is going to be solid because it's greater than or equal to. So now when I shade the other side, it's greater than, so I'm going to look, it's going to be greater than the y-intercept, so I'm going to shade this side here. And if you notice, my overlapping solution area is right in here. So there's my solution. Okay. So our examples aren't always going to be in slope-intercept form. So we're going to start out in the first one and say y is equal to -2x minus 3. So I'm going to graph that one here. My slope is -2, so I'm going to go up 2 and over 1 like this. Okay, this one is also going to be a dashed line. Okay, now because it's less than, I'm going to look at my y-intercept, and to shade below the line would be here. So this means I'm shading on that side. All right, now I'm going to work on the next one. I'm going to put it in slope-intercept form, -y less than or equal to -2x minus 1. Now I'm going to divide by -1. Now don't forget, because I'm dividing both sides by that negative, my y is actually greater than or equal to 2x plus 1. All right, so when I graph that, I start at my y-intercept of 1. I'm going to go up 2 and over 1. All right, down 2 and over. There we go. And this one's going to be a solid line, because there it is. It's going to be a solid line because it's greater than or equal to. All right, and now when I look at my shading, okay, of that line, since it's greater than, my shading is going to be above the line, the y-intercept, and it looks like my double shaded region is going to be right in here. So this is my solution. Okay, looking at number 4, okay, I'm going to first put it in slope-intercept form, and I get -3x minus 3. So when I graph this one, my slope is -3, so I'm going to go up 3, 1, 2, 3 into the left one. There we go, and that one's going to be dashed. Okay, it's going to be greater than -3, so I'm going to look at my y-intercept of -3, and anything greater would be this direction. So I'm going to shade everything on this side. Okay, and then I'm going to look at my second equation. In this case, it's x is less than 4, so I'm going to think of Vux. I'm going to go to 4. Okay, so here's 4, and it's going to be a dashed line. Whoops. Dash vertical line, and it's going to be less than it. So if I look at that, it's going to be to the left. So you can kind of see your shaded, double shaded area is in through here. Okay. All right, where this double shaded area is right in through here. And that's our solution. Okay. All right, with all of these examples, it's actually very easy to check your work on Desmos. So just bring up Desmos, put in both equations as is, and see if your graphs match up. All right, so if we want to see if an ordered pair is a solution, we just want to plot the point on the graph. If it's in the overlapping shaded region, it's yes. If it's on a solid line that's in that region, it's a yes. But if it's on a dashed or dotted line in that region, it's a no. And it's also a no if it's at the intersection of a solid and dashed line or dotted line. So let's look at the ordered pair. Okay, we've got the ordered pair 0, -1. It would be right down here. That is clearly in the shaded area. It's the double shaded area in this example. So this would be yes, it is a solution. Okay, now these shaded regions represent the overlapping shaded regions. So had we actually graphed this line, it would have looked like this. And then if we graphed the other line when we shaded it, it would have been going this direction. And that's how we got that double shaded region, okay? So looking at number 6, if I look at -3, 1, -3, 1, the ordered pair is right there. That's clearly not in the double shaded region, so this would be a no. All right, if I look at the 0.30, that's actually right on the line of the double shaded region, but because it's on a solid line, it is included as part of the solution set, so that would be a yes. But the ordered pair -2, 0 here, even if it was on that dash line, although it kind of shifted when we printed, had it been on that dash line or even in the white area, this would be a no either way. Okay. Now our last example, we just have a question for the following system of inequalities. Determine which ordered pair satisfies the inequality. All we have to do here is plug the values in, and it needs to be true for both. Okay, so this should be true for both. So I put in the first ordered pair, -1, -3. My y is -3. Is that greater than 1/2 times -1 plus 1? So -3 is greater than -1/2 plus 1. -3 is greater than 1/2. Well, that's a false statement. So I don't need to go any further, okay, because that one is false. All right, with B, if I plug in 1, 2, my y is 2. 2 is greater than 1/2 plus 1. 2 is greater than 1 and 1/2. Well, that's true. So I'm going to continue on, and I'm now going to check it with the second inequality. My y plus 3x, so I'm going to say my y is 2, plus 3 times my x is 1. Is that less than 6? 2 plus 3, is that less than 6? 5 less than 6, that's true. So we know right now the following system, the ordered pair would satisfy this one. Okay, so this is a true. Let's just check the other two. So for 2, 0, if I plug in my y, 0 is greater than 1/2 times 2 plus 1, or 0 is greater than 1 plus 1, 0 is greater than 2. That's a false, so we don't need to move on. Okay, and then the last one, the 4, 6, I plug in my 6 is greater than 1/2 times x, which is 4, plus 1. 6 is greater than 2 plus 1. 6 is greater than 3. Well, so far that's true, so let's check the second one. All right, we plug in 4, 6. We've got 6 plus 3 times 4. Is that less than 6? 6 plus 12. All right, we've got our 18 is less than 6. That one's false. So it's not true for both. So it looks like the only answer is B. Okay, so if you want right now, you can just work on the exit ticket and the homework. Thanks. Bye.